All right, lesson 1.2, we're going to take a look at the process of chemistry, and you've probably had something along these lines at the beginning of every science course you've ever taken. We're going to look at the scientific method.
And also, of course, to identify the components of the controlled experiment within the scientific method testings.
And then we're going to look at scientific models, which are something that we do use pretty extensively in certain areas of chemistry, and explain their uses and limitations. So the reading, of course, from this, you would want to read Chapter 1, Section 1.2 to have the reading that goes along with this.
The scientific method is defined by a method of investigation involving experimentation and observation to acquire understanding of the natural world. And of course, there are steps, which are something you've probably seen for years now. And the first step, of course, is to identify the problem you want answered. Oh, well, for example, you have this odd smell in your science room, you identify the problem.
Okay. Then, of course, gathering data. We could walk around the room and see where the smell is most intense. We could search our memory banks and say, well, gee, this smells like a solvent, or this smells like baked good, or whatever this.
Well, that's going on to the hypothesis, actually.
Okay.
So you'd hypothesize as to where and what this thing might be, this smell is coming from, and then, of course, you go to test the hypothesis. You either go to find the source of the smell, or you find someone who is knowledgeable on smells, and says,
or you do another test. Gee, maybe this is this, and we compare it.
I don't suggest doing a flame test.
Not
though.
a good idea to taste things in a chemistry lab either, unless you're specifically told to do so. But and then we've got a little chance for feedback. If our data from our test of our hypothesis agrees with our hypothesis, then we might say, okay, we have some support for our hypothesis. If the answer is no, then we might go back to the hypothesis step. And, well, we thought it was a chemical spilled in the storage room, but now it seems to be concentrated near a student desk, then maybe it's
one of our students smell bad.
Some drink they brought in with them or something that spilled. But so there's, and this is kind of a very general representation of the scientific process. But, in any good science investigation, most, if not all, of these elements are going to be there.
Yep.
So on this slide, there's no doubt there's a lot of text. So if you need to use the pause button, when you're not finished, when we're done talking, just use it. So we're going to talk about elements of an experiment. So, of course, what is a controlled experiment, which is what we're very often doing in laboratory science anyway. It's a carefully planned investigation or an experiment that we use to obtain some sort of useful data or result that we can interpret later.
So in every controlled experiment, you have to have certain guidelines to follow and methods for testing things. And in doing this gives you different types of variables and controls you want to look at. So the first thing you want to look at is the independent, and it's also known as the manipulated variable. This is the factor that is deliberately set by the experimenter to test the dependent variable. So I change something, on purpose, and I want to see how that changes the rest of the system that we're studying.
So, for example, something that we might look at in chemistry is the solubility of something. So we might say, how does solubility vary with temperature?
Yep.
So we could set up some different amounts of water, and we would put them at different temperatures deliberately. I'm going to try one that's close to the freezing point, one at room temperature, one that's hot, and one that's boiling. That would be an independent variable. I can deliberately vary the temperature,
and then
we have to see some other effect on some other variable.
All right, the next one, of course, would be the dependent, also known as the responding variable. This is the factor that would be observed when the experimenter changes the independent. So on that last example, we change the temperature. What's being changed by that, of course, is the solubility of the material.
So we would investigate how much or how little of something we could get to dissolve in that amount of water. And then, of course, to keep things fair and so our results have meaning, we need to have variables which are controlled. So these are things that we would intentionally hold constant so that we can actually have some true meaning of our results. So what might you come to mind right away as something you want to control in that experiment we were discussing?
The amount of water present.
That would definitely be a key factor.
And there's some
Also,
other ones.
what we're dissolving.
Yeah, you don't
we're
want to
gonna
go
wanna
between
use the same solute every time.
It's not like I want to use salt in one and iron in the other.
Right, so
that wouldn't make sense.
So these are, kind of intuitively obvious to anyone who's ever done a science fair project or anything. These are the things you want. You want to try to control as many variables as you possibly can, especially if they're ones that you think might also affect your independent or your dependent variable.
And of course, lastly, you have to observe and record through observation and data. This is the information that you gather from doing these experiments, and this is what we're going to do in any of our labs. We're going to have independent, dependent, controlled, and of course, we make observations in our labs, and you use that to answer questions about the other factors that are present.
Okay, so again, I think most of you have had this already numerous times, so we're kind of going through this quickly. If you do have questions, though, please write them down on your notes and make sure you ask them the next time we come to class.
All right, so this is one thing we use in science a lot are models. It's very hard for people to imagine things they really can't see. So in science, we use a lot of models, either a description, graphical, mathematical, or three-dimensional representation is what we use to help you understand. Like for cells, we can see cells, but it helps if you see, a large model. And in chemistry, more likely or not, we don't see atoms very easily. We can actually these days, but it's not an easy thing to do. So we have a lot of 3D modeling that goes on. So good models are predictive, they're simple, and they include all the important variables that we're studying and are good. That's something you have to remind, that it does predict exactly what that should do based on what's given.
Okay, so in chemistry, as Mr. Hunter already alluded to, we're dealing primarily with things that are we model them because they're too small to see or they happen too rapidly. So the atom and structural models of molecules would be two things that we model a lot. So what we've got in our picture there on the left is actually the compound sodium chloride. You and I would call it table salt. And then on the right is a kind of model that we have that would represent a crystal of sodium chloride. So it's got the green balls to represent the chloride ions, and the blue balls would represent the sodium ions. And you can notice that they're in a 1-to-1 ratio. So again, we know that there's exactly the same number of sodium ions as chloride ions in a crystal. So this model is
it's pretty good.
reflecting the variables that we know about that, at least in some ways. And when we look at the cleavage and how the crystals tend to break when you put stress on them, this model, we can't really show it because it's a still picture, but this is fairly accurate in that respect too. Now, no model's perfect. This one is held together by little magnets embedded in the balls of wood. So that's obviously not how real ions are held together. So, but models have their limitations.
Okay.
No model's perfect.
Alrighty, let's go look up some questions.
Right, so for our post-video questions for this experiment, we're going to do something a little different. We've recorded a little video clip, and just to make sure you understand what you're looking at, the syringe in the video clip has a trapped amount of gas. It's air. And then the hose at the end of the syringe is hooked up to a sensor that can sense the pressure. And we're getting a readout on the screen of the blue device that's showing us units of pressure. And you don't even need to worry about what the units are, but the bigger the number, the more air pressure.
Okay.
So what we want you to do is to watch this video. We're going to play it twice. And then we want you to try to answer those questions based on the observations in the experiment.
So something to keep in mind is, as you're watching this video, think about what the independent variable is, the dependent variable, and of course what we are keeping controlled. Also, what appears to be the relationship between these variables. We mean, are they directly related, indirectly related? That means as one increases, the other increases, or as one decreases, the other one increases, or some kind of relationship like that. So just keep that in mind.
Try to answer those two questions, and we'll discuss it next time in class.
We'll go over the answers with you tomorrow. Have a good night.